Hi, so let's see how this game works. Okay, you see there are some sounds, images, and etc. And you get some coin, get a sort of double jump. And this is made starting from a code from Dafluffypotato that made a video and put some code for a platform 2D platform game. So that's what I made some changes. I don't know if I can make you see what was the original code, if I get it somewhere. Maybe let me see. Let me see, maybe it's not this one. This one is, I think, code by Ross. Just wanna make you see that there are different kind of tutorial things like that you can, and you find them on my blog or my YouTube channel, a lot of this, and so you can take a look at their code to see how it works. You see here there are also some enemies, so you can also start from this. Quite nice. But this is not what the code by Dafluffypotato. So this is, I think, don't know if it's the same one. Yes, it's the same. This is another code that shows you how you can start from the very basic. There are no images. There's just a way to jump around and to make this kind of map here. If I'm gonna make it a little shorter here, you may see the edges. Okay, you see you can change it like this, and this also can be taken as an example. Here you see when you press the key, you move your sprite, etc. And let me see if I can get you to another example here. This is another example by Dafluffypotato here. It's not, I changed it a little bit maybe. This is not scrolling. Here you see the frame rate, and the code is not that much big. Maybe could unite this one in just one GitHub repository to make you see how it works. So I cannot find here the original one, but let me check another bit on another hard drive. If you can wait a minute. I would like to make you see the original codes to make you see what are the difference with what I changed in it, and then maybe we can go and see how to build it from scratch. here I got some different of these folders with the code by Dafluffypotato. Let me see just if he made different tutorials. Oh, this is, yes, I taken from this one practically, and you see there are some parallax, something here when it jumps then it stops, and it's very nice. It's different from mine, it's nicer than mine because the changes I made, you see there are some animation on these little sprites, completely dark, colored just a little bit with a, there are this grass, this thing, and this is what I can say, an endless world with parallax, etc. And basically it's always like this. It's, although it's very simple, it can show you how to make basically a platform. I like the sound too. Mine is not so good. I'm gonna change it maybe. So this is the original code, and it was just 233 lines of code. So, and there is the music, the sounds, and everything, player animation. And so let me copy it on my new hard drive so that we can check some differences. Let me see. Let's see how this works before I see the changes I made, because when you change code, maybe you mess it around, you make it more complicated. So let's go in this, starting from this code of Dafluffypotato to understand how he did it, because it's very nice. So, and let's also see how to change it. So let's save it as tut1.py so that we don't change the original. There is also this one, maybe was something that I changed it maybe. Okay, you see the interesting parallax thing with the surfaces that gives you a sort of 3D dimension here. There is the more distant, and the other that are less distant, etc. Okay, so let's see. Let's get to the original code here. So how this works? So it imports Pygame, sysos, and random. So it imports these three modules. To make it fast, I'm gonna copy some of this, and then it's gonna do this clock, Pygame time clock. I will put it maybe under this one, and this I will put it here. Then this one I wanna put it down here and put it down here. Now we get this Pygame mixer pre-init. Maybe with the new version of Pygame, you don't need this pre-init, you just could go and do init. And so we will do it. So we wanna also see how it works and maybe change it also a little bit. This Pygame.locals is for some attributes, some variables that pass, so that we can use without using Pygame dot at the beginning. And so we surely have to initialize Pygame with this always. Does some sort of things to fix up things for us. Now this number of channels, etc. Maybe we don't need to do it, so we're just gonna do this. And then we have for the frame rate this clock. So this basically is something that you always do with Pygame. Another thing that you do, you can go and give it a name to the window, and let's call it exploring new land, let's call it like this. And that's we have the sides of the window, and then I want to see also how to maybe make a bigger screen easily. Okay, but let's for the moment stay at this. And then we have this the screen. This is the screen, represents the screen where everything is displayed. It has this set, it comes from pygame.display set mode, this function here. This method set mode that would get the 600 for 400 dimension, and then 0 and 32. Well, let's not explain that, just leave it there. Then we get the okay, this is to another screen surface. It's not the main surface, and what the Dafluffypotato does is to display things on this image, let's say so, this surface, and then to scale it on the screen, so that because the pixels, the images are even smaller than what you see on the screen. In fact, if you go here, and if I should do this, you see that the real images are this, and so you can also see that what happens where you don't see the screen. You see those, see that these images on the background, just the level that is more behind follows the, you see the movement of the player, so it seems there is always there, but it's just moving around with him. Instead, the earth, the terrain, is adding, when it goes up, always another image there, or a number of tiles, so that it goes on forever. Add some grass randomly, and when it goes to the left, so it doesn't use a lot of memory, but just the one that you see on the screen. So this is the real image. So you see how tiny is the pixel and all the tiles. And okay, so you see that now we haven't scaled it, and instead, if I scale it here, I give it a smaller size of the display surface here, so that is practically the double of the size. And so you don't see that, and here we have nothing, and it's just added when it scrolls down. And for example, I could also, well, let's see what happens if I do even this one even smaller, like 150 and 100. Okay, you see, you don't actually see because it's played a little down there on the screen. Let's do 200 and 150. Okay, you see it's even bigger. No, there's actually It's not in the middle. So if I make this one a little big, you should see what the Dafluffypotato wanted to see here on the middle of the screen. So that's what this display surface is for. You display the images here, and then they are scaled here. And if you want to see where this happens, it happens here. And the last part where the screen is you blit Pygame using Pygame transform scale, so it transforms every time, every frame, what is on the display to the Windows side, starting from 00 on the top left corner of the main screen, and so it is double the size. And here it happens. And instead, if you want to see when things are displayed on display, let's see here, for example, this is the background color that it's filled in the display surface. Here a rectangle is displayed on display. That is I think is the background object. And also here we get another two rectangles, I think, of the background object, as you see in the parallax effect. Here instead it is blitting the tiles for the earth, always on display here. And where else? Here we are blitting the player, like with the image, or the image flipped when it goes to the right or the left, and in a position depending on the scroll system that it makes to make it appear that something is scrolling. And then I think this one is the last thing. It says we display. Then you get this, and so here at the end, everything is doubled the size like we've seen before. And do not this has nothing to do with this one. This is just a name that we give to the surface that is then scaled. This one is different. It's just the module, a module of Pygame to update the screen. Okay, and now now that we explained this one, the fact that we have two surfaces, this technique used by the Dafluffypotato to make this a bigger, you see, like zooming into the game with these two surfaces, to say so. Now let's see what else he has done. So then we have move right, move left, vertical momentum, and eye timer. These variables are needed variables to control the player movements. So this is used to control if it's going right or left. When he's standing, it's not going neither right neither left, so this will be both false. This is to see if it is jumping, and then we will see how he did it. This is a true scroll, is used instead to control the camera, to scroll things away from the screen, so that it seems that the camera is moving with the player, but the player is not. It's not moving. It's not really moving. Let me show you you see that here is standing, nothing's moving. If I go here on the right, everything moves to the left. Something moves in the back slowly. The more they are near, they move faster. The things that are not near move slower. So you see that this rectangle here will go away. Instead, this one will remain on the screen more. This will be, of course, faster in this direction, so that it means there is more near. You see that there is a certain and you see that now it is in this point, and you see that it goes until this point, and then it doesn't move anymore. And also here, so it has a certain, and then it goes back when you stop. Everything goes back to the middle, like this. So this is to control the X in Y position of the scroll, because there is also, when it jumps, you see that everything goes down, and when you go down, everything goes up again. This chunk size, don't remember what it is like, but let's leave it there. We will find what it is like. This is the range 8, maybe. It's linked to the way it's, so this fact that I describes that when it goes to the left, it goes a little bit to the, for example, let's change it to see what this does if we change it. Okay, we cannot divide it by 0, of course, because this is, let's put it to 1 instead. That it means that it does nothing. Okay. This is used for the let's put it to 2 for the terrain position, something like that. Okay, it's for the yes, it is there. So if we put it to 8, we should have or fix it down, so it relates to this thing here. So let's, and here is generate chunk, and let's see all the function that we have. Don't know why this global is up here. Well, we have the animation frames. We took this one later. Then we have the load animation, def change action, animation database. It's another dictionary. And then we have these two keys of the dictionary, where we the value comes from this thing, and these are the animation and returns animation frame data. So it takes the folder where the images are and 2 numbers here, so it will probably load the images, convert them to make them faster, set an invisible colors to don't see the background of the image, and then it will make animation frame, create this dictionary with animation frame ID, that it's like animation image dot copy, and animation image is this one, is this surface here with this image. So you copy this image under in animation frames, and for E in range frame, and frame is the frame duration for frame and frame duration. So for each, for 7 and 7, so for the same amount of time, it will append animation frame ID. So it will append 7 times this image, so that it will be shown for 7 frames the same image, so that it will not change the animation too fast, but it will stop for 6 times. I don't know if this is something that we can optimize. We could change this, make it in a different way without having to, but we could have just made a simple if and say if x is more than 7 and it's less than 7, then animation frame is equal animation frame ID, animation frame 0, or count with a counter. If it's well, let's leave it like this. So but the sense is this: you got 7 image equal image in this dictionary, where the frame ID is run. This is the name of the action. So when it's running, it will do this animation. When it's in idle position, it will do the animation of the idle animation that are stored in animation frames idle, and with all the images, 7 image equal the different animation for the idle position. Okay, so for example, this could be animation frames, and it will be, for example, idle, and it will be equal animation image, but for each frame and frame duration. The frame duration we are seeing frame duration is it's equal, for example, 7. So for each animation, for 7 times practically. And so here for 7 times, it will animation name string n. So here there is this 0 here. So this will be practically animation name would be have the path of run /run _0. Okay, and if you go here and see player animation, you see run 0 and run 1. And so you will have for range time here, what it means that animation frame data. So in animation frame data, we will have data we will have, this will be equal to a sort of we will have two animation frame. They will be run 0, run 0, run 0. Okay, we'll have seven times the same animation frame ID that it's down here for E in range. So animation frame data that will append this one, and it will return animation frame that will return this, and then it will have it when it does the first time. When it does the second time, it's because it has the numbers here, so this will go on for 7 times, and then will be run 1, run 1, run 2 for 7 times. We return this, and so let's go back where in this animation database under the key run we will have this list of animation frame ID of strings. These are just strings with .png. Okay, and no without png. Okay, just run 0, run 0, run 0, run 1, run 1. Okay, etc. These are all strings, and so it will go down here. These are strings. Okay, it returns list. Return list of list of strings. Let's see. And so frame duration. The path is this is a string. Frame duration, it's a list. Okay, so we see here we are given a look to this load animation, how it works. So now that we understood this, let's get back to our code here, so where we rebuild the code, and let's put this thing all together, and this we will put this one at the bottom here because we want to put the function up. Okay, so now we get what load animation is, and we also have this animation database here. Animation database. Okay, so we got into this dictionary 2 of the animation that we need to see the animation of the sprite. Let's see if we can make this one more clear, like this, and put this one down. let's see if this one works, just to make the code a little nicer, maybe, or maybe not. If you prefer, leave it like this. And so let's go and see what else we got. We got game map. We got game map. This will contain the map. Of course, let's put it there. Then we have the sounds, and to load the sounds, we got pgmixer.sound jump, and we got the grass sound. You see that? That we have two sounds for the grass. You see, dun dun dun. So and so we have a list of two sounds for the grass. Okay, and then we have the volume for the grass sound and for the okay, for the two type of, it's a little bit lowered, maybe because maybe it was too high. So let's go here and say sounds. Then we have the music that never stops with this. Soundtrack loop. The loop is with this -1, so it will go on forever. Then we have player action idle, frame equals 0, and player fit equal false to see what is initial position. Initial action, what is the initial frame, what is the, if it's looking towards left or right, and now it's looking towards right, so it's false. It's not flipped, because just use one image for that looks towards right, and then we flip it when it goes towards left. Then we have the sounds, the timer for the rest sound. As you see, it goes with two different sounds, and we'll also have some timing to not make it sound too many times, but just at the right time. Then we have the player rect. So this is the initial position, a rectangle that defines the starting position 100 and 100. The weight of the rectangle where the sprite is at 5 and 13. This is because the computer Pygame module will point at this rectangle in this area, and it will see that in this area we get a player inside under this name, so we can use player rect to check if the player is colliding with other things that is in the same position. So we know the player rect points to this rectangle in the screen. Okay, so this is very important for the game to see, to interact with the player with other things. Then we have this coordinates of background objects. So let's see how this is made. For each background object we got a list of something of one number and another list with 4 number. So let's understand how these background objects work. This is just to, okay, like everything, you know, that seems to be an object on the screen, we got to know more than the image. It's important that the image that we see on the screen is related to a rectangle, so that we think to the game, not just like images something, but like little areas that are that changes their position, and so that the computer can store the position, and the area is storing somewhere. We need to store the position of this rectangle in the area that they occupy, these rectangles, so that we can see where to show them, and where if they are on top of something, if they are next one onto another, and so to make the rules of our video games, to see if you are touching something, you are falling down, etc. And so the background, our objects are this used to make this parallax effect when you see the things in the background that moves while the player is moving. And so we get these two parameters, let's say. This first one is probably the velocity, so that this one is 0.25, maybe it's slower, and this one is faster, or it's the opposite, I don't know, we will see them later. And this one should be the x and y position, and the width and height, because these four numbers will probably be used to make a surface with a rectangle like this, with a Pygame rectangle area like this. So this is an area, a Pygame rectangle area that correspond to where the player is. So we will display the player here, and we will have also, so we got two things to do. We get to blitz the player at 100, and then we have to follow when the player will change his position eventually. We will also change the position of player X. Even better, you may position your player with the player X coordinates. So when we change the player X coordinates, we will have the new position of the player, and we will blitz the player automatically, if you can say so. We will see this one later. So this is the velocity of the background objects, someone faster, someone slower, and this is where is the starting position. This is the width, 70, it's like bigger than 40, and here is 40, it's like this one. Another object, this is 100, it's even bigger, this is even bigger. And so I think that and this is the height. So you see everyone is height the same. Let me check out a little bit here. You see that this one is, I think you see 130, 40. It's to see it better, we should get back to see the original position here. Okay. So we got 1, 2, 3, 4, 5 of this one. 1, 2, 3, 4, 5, and you see you got 5. Even if there is also a 6th element here. And 1, 2, 3, 4, 5. This one, for example, starts start at 120. I think could be this one. 280 and 10. This is maybe should be this one, because you see that, remember that this is 600 for 400. 600, so if here is 600, here we got 300 in the middle, so 280 should be this should be 300. In fact, it's larger, the larger one, 120. This is the other 100, and it's, if we go down, we're gonna see that maybe we cannot go down because, okay, but if we, for example, let me change the this one so that we can fall down, and we will see that they are all to the same sides. Someone goes down slower, this one stays always on top, as you can see, and this one follows. It's fixed there. Okay, and let's get this one back to their original size so that you see that they are then scaled down. So okay, everything is like this. Okay, now we are seeing the parallax objects, the 5 parallax objects, and there is also a 6 parallax object. It's not here. And then we have the collision test. We will see it later. The move function here, that will see if you go on top of a tile so that you don't fall down. And then we have the final while loop, while true, while it's true, so forever it will do these things for always. Every frame will go until here and then go up here every frame and redo all these instructions. So this is the loop that makes the game go on. Every frame it makes something change. So what it will do every time, and it will display fill the color here. So let's go and see if we can run our code. That is this one. That is not complete, of course. Has just some declarations, loading some sounds. It does nothing here, but we will, while it's through, we will display a color. And at the end, we will set the frame rate to 60, update the screen, and eventually screen bleed, transfer scale, bleed display screen, where there is still nothing, so we will not see anything. To make it work, we must also have the chance to exit from the while loop, otherwise it will go infinitely and we cannot close the window. So for the event in Pygame, event.get, so for this we will take a look every frame what is happening in the pygame.event.get. That is a list of the user actions. So if the user quits the window, we will quit Pygame and exit from the Python interpreter. So this code now should eventually work. We get just one function that we don't use, and let's see, maybe it could be some problem here with this animation that I made new, but let's see what happens. animation takes no arguments. So I forget something like class animation. Okay, I forgot to put double underscore here. Permission run found in working directory. So I've given a wrong in path is player animation. Let's see how we should call this one. Player animation run idle. I think there is a player animations. There is an S here. Okay. It seems to work. There is nothing in it. There's just the color, and it's, for the moment, it's right. Okay, let's see what else we can do here. If we can see something on the screen. And so we got here the if whereas sometimes this is to the this is to make the double sound of the grass, to make alternate one sound with another. Then there is this true score 0. We get the width, the control of this width of the scrolling towards horizontal scroll. We can say horizontal scroll. How it works. So it takes the position of the player. So player rect.x, as I said here, pygame player rect equal this pygame. So player rect.x it's equal 100. So it's 100 minus true scroll 0 minus 152. So what this means, divided by 10. So true scroll 0 at the beginning it's 0 because through scroll we got it. Where is through scroll? Here 0 0. So at the beginning it's 0. So correct 100 minus 0 minus 152 divided by 20. So we could take the calculator to see this how it is. We got 100 minus 0, it's nothing. So minus 122, it's like divided by 20, it's minus 2,6. 2 minus 2.6. For event and by game event again. We could also send this to avoid the randomness of things. The floating point to know if something should change. apparently not. Let's see. If it's more smooth, maybe. Okay, let's leave it like this. True scroll 1 adds plus equal this. So true scroll so if it's the first time, it's -2 and 6. The second, in the next frame, it would be, let's say that player rect, if it moves, it goes forward. Let's say, I don't know, if right equal true, it goes through 2 every frame, let's say. So we will have that 100, it will be 102 minus 2.6 minus 166. Divided by 20, so it will be 21, so it will go back. No, sorry, here it is plus. Okay, 26. So if I made it wrong or I made it right, this should go. Well, this should go back, have some number. Let's go on and see what happens. So scroll equal to scroll copy. So this one will copy this new numbers. And then we will scroll 0 equal int scroll 0 and scroll 1 equal int scroll 1. So maybe we could avoid this doing this. Yeah, maybe that's the same, maybe. And okay, then we will pygame.drawRect display 780. This is the fastest, parallax last object, let's say, so the fastest, the farthest object there is. It's 0, you see it's set from 0 and it's down 120, it's 300 long, yeah, the width, and 80, it's not very, yes, okay, this is the one that you see in the back. we see this one that is 300, just like the window, because the display window is 300 width. So in fact, if I go here and write 200, see what happens. You see that, okay, it's there. You see here 200. Okay, now let's go a little 300. Let's put this back to 300 and 18. If I put this 1, 2, 3, you will see that it's just a line now, as you can see here, of 3 pixels. So let's go back to what was before, 80, so that you don't see it. The background objects, for background objects, that you know is this one for every row here. This is object 1, parallax object 2, etc. And so for every one of these, to see them in the background, object background, it's gonna draw this in this way. So we'll have the position will be background object 1, 0, 1, because 1 is this 120, minus scroll 0, so I need to scroll all this in the multiplicative for background 0. Okay, multiplicative for the velocity, so this will go slow. It's far, and then we have the width in the x, in the y coordinate, on the y position, the height. So we have 1, 1. So this is the x and the y, and minus scroll 1. This is scroll 1 is calculated related to the position of the player, multiplicated for background object 0, always for the velocity, in which, because depends on the distance in the background. Then we have the width. There is 1, 2, but 0, 1, 2 is 70, and then we have the last one. Where is it? 1, 3. There is the height. So it will draw a rectangle in this position, changing the position depending on the scroll. That depends on the player position and where it's moving. Okay, so this is the background. If background object it's equal to 0.5, so it will. Okay, this is the rect. Okay, this is defined to the position where it should be breathed, and so we will. If it's 0.5, it will begin to display this one at. Okay, we draw a rectangle onto this surface. This is the color in this position. So this is to change the color of the object. So one will be bluish, and this is because the one that moves faster are clear, the one moves slower are darker. In fact, you see that this one that moves slower, it's darker. because the more this is height, it's lighter, this is darker. So this is lighter and nearer. This is darker and farther. Okay, and yes, nearer are faster, and this is slower. Darker, farther, slower, lighter, nearer, faster. Okay, lighter is faster and it's nearer, darker is farther and it's slower. Okay, now that we made the parallax objects, we got these tile rects. Okay, this is interesting. And okay, let me put this one, now that we understood what we've done here, we're gonna put it into our code, and we will put this one down here. It would be maybe nice to put this one into a sort of inner function. Def parallax. We have to put also the coordinates here, or the data for the background objects. Okay, you can see here our parallax objects, and they just adjust themselves at the beginning. So the player is not here, we cannot move it, so this will not change. But you see the 6 parallax objects here. So we have put them into a different inner function so that we have a, let's say, a better, cleaner code, maybe. Okay, we have done some work here to see how the code of the Dafluffypotato works, and okay, we want to stop for the moment for this first part, and we will check and rebuild all its code in the next tutorial. The second part, maybe the last one, I hope it will be the last one, and we will see how we see the player, the movement, etc. So I hope you enjoyed this analysis here of the code to see how he made something in here, starting from scratch, rebuilding all its code that, you know, watching it this way may be a little confusing if you are not familiar with Pygame, and so you may be asking how these things work together, how the process for showing things and on screen interacting with them works. So thank you, and see you in the second part. I hope it will come soon. See ya.